So we worked on side splitter in the last lesson, and I want to give everybody a heads up that this section gets a little bit difficult. There are some people that really struggle with partitioning a line segment. The concept goes with all the other similarity concepts, so it does fit, but you just need to pay real close attention to this one because it can be a little tricky. So we're trying to slice up the segments, essentially. That's what partitioning means, is to break it into pieces. We want to do it proportionally and try to use the same similarity concepts as we go here. Segment AB lies in the coordinate plane with point P on segment AB. So P falls on the segment, such that AP to PB is 1 to 1. Now this is important that you understand how ratios work. When you see that colon there, that tells you how many parts are on the left, how many parts are on the right. So if you see 1 to 1, that means there are 2 total parts. And one of those parts is on the left, and one of those parts are on the right. So AP and PB are both 1 part each, therefore they are equal. And so to show this, you would put P right in the middle. You have 1 part on each side, and that's the ratio 1 to 1. Okay, so that's part A of exercise 1. What special point is P? Well, it's going to be the midpoint because you have 1 part on each side. And we know how to calculate midpoint with coordinates. We just take the x's and average them and take the y's and average them. So the x's come out to 6 over 2, which is 3, and the y's are 18 over 2, which is 9, and we have our coordinate for P. All right, now, partitioning is usually not quite that simple. We usually have to do a little bit more work than that. But if you have a 1-to-1 ratio, you're essentially getting a midpoint. All right, exercise 2. In the following graph, segment AB has endpoints at 0, 10, which is here, and 15, 0, which is here. We want to locate point P, and I know it's not given to you there, such that AP to PB is 3 to 2. Okay, so the first thing to do is draw triangle AOB. The origin is marked O, so just draw triangle AOB. And do it without the grid, just put it over here. And we want to mark the approximate location on P. Now let's think about this ratio, this 3 to 2. That tells me that there's 3 parts on the left and 2 parts on the right for a total of 5 parts. So AP is 3/5 of the whole segment. Okay, AP is on the left, 3 is on the left, so AP represents 3/5 of the total distance from A to B. And then that 2 means 2/5. So that means it's a little bit farther from A to P than it is from P to B. Okay, and that's how I've drawn it. P is a little bit past midway between A and B. So if I'm using the grid and I'm trying to find that out, well, actually, let's just, before I get to the grid, let's go on with this. On your diagram above, so draw that vertical line. Once you've located P about 3/5 of the way down, if you draw that vertical line and mark it with point C, first off, it's parallel because they're both vertical. So they both have an undefined slope, so they must be parallel to each other. But for part C here, the ratio for OC to CB, it's got to be the same as it was from AP to PB. And this goes back to the last lesson. If 2 lines within a triangle are parallel, the side splitter theorem applies, and the ratios will be the same. So the ratio here was 3 to 2. The ratio here is going to be 3 to 2. So if I say, all right, well, then it's some multiple of 3 and 2. If we have 3x and 2x, and we know that it's 15 units because point B was at 0, 50, or 15, 0. Well, then if OC represents 3/5 of the way and CB represents 2/5 of the way, I can say 3x plus 2x equals 15. And so that solves out to 3, which means my multiplication factor was 3. So it must be 9 units to C and then 6 units from there to B. So the coordinates of P, if I use the grid, it just comes right up to that 9, 4 coordinate. All right, now there is a way to calculate that directly without having to go through point C. This is the best way. The best way is to use the x-axis because it's a lot easier to just count straight across using that ratio, to take that 15 units and split it up into 3/5 and 2/5. But what you could do is notice that the slope of AB is down 10 and over 15. Split the down 10 into 6 and 4, that's equivalent to 3 and 2, and split the over 15 into 9 and 6. So you can do it with slope as well. I think side splitter is going to be your best bet, but if you prefer slope, you can do it that way. You can get there that way. Okay, so looking at the next page, it's easiest to use horizontal or vertical line segments because it's easy to count them. So on this grid, we've got point E at -6, -4, and point F at 8, 3. And we want to find out where point G should be so that segment EF is partitioned in a 3-to-4 ratio. Okay, a 3-to-4 ratio implies 7 parts, 3 of which are on the EG segment, 4 of which are on the GF segment. So 3/7 and 4/7. So if I draw a right triangle with EF as a hypotenuse, what I can then do is label the legs. So this vertical leg is 7 units. This horizontal leg is 14 units. So since it's a 3-to-4 ratio, what I can do is say that from E to the point directly below G, well, actually, I don't know where G is yet. From E to the y-axis is 6 units, or is part of that, and C to the vertical line is another part of it. That ratio there is going to be the same as the ratio going up the hypotenuse. All right. So if I've got 14 going across, that means 3x and 4x has to add up to 14. So looking at that, it's saying that x equals 2, and therefore 3 times 2 gives me 6. I'm going to travel 6 units this way. All right, so I can locate point C first rather than locating point G first. So let's just go back to the beginning of that. If I have triangle EF and then whatever you want to call this point down here, if I have that right triangle, it's easier to figure out where the point is horizontally than it is to figure out where the point is on the slope line. All right, so if I take those 14 units and I partition them into 3x and 4x, I can figure out where point C falls. And we'll do more examples of this in class as well. All right, so looking at exercise 4, let's try to do this one as well. We're trying to get a 3-to-5 ratio. The endpoints are here at -5, -6, and 11, 18. This one I'm trying to do without a grid, just trying to draw it. Okay, and if I draw the right triangle, I'm basically saying that this point is somewhere in quadrant 3 and this point is somewhere in quadrant 1. How far is it across and up? Well, if I'm going from -5 to 11, that's 16 units horizontally. And I'm going from -6 to 18 is 24 units vertically. It's not drawn to scale, but it doesn't need to be. It gets the point across. So if I have 16 horizontal units and I'm supposed to split it into a 3-to-5 ratio, then I can get that x coordinate by saying 3x plus 5x adds up to the whole horizontal distance. 8x equals 16, x equals 2. That's telling me that the distance from my first point has to be 3 times 2 units. Okay, so traveling 6 units from -5 takes me to +1. That's my x coordinate. Likewise, for the y coordinates, I have to take the 24 units and split it into a 3-to-5 ratio. So 3y plus 5y equals 8y, y equals 3. That doesn't mean the coordinate's at 3. It means that I have to travel 3 times 3 units from point D to get to my spot. Okay, so the coordinate comes out to -6, which is where I started on this bottom line. -6 plus the 9 takes me to +3. So that's how that partitions. Exercise 4 is far trickier than the one before it because I don't have a grid. However, if you'd like to use a grid, you certainly always may. What I want to get home to you here is if you start on the left, if you start at point C and you move across, you can figure out how far to move across and then apply that to the x coordinate. Then you start at the y coordinate for point C and figure out how far to go up and apply it to the y coordinate. Okay, so that's why I started at -5 and I started at -6. All right, let's go to exercise 5 and we'll be done. Segment EF has endpoints as listed. Point P lies on that segment at -312. Which of the following is the correct ratio? Okay, so to get from E to P horizontally, it's going to be from -7 to -3, which is 4 units. To get from P to F, I'm going to be going from -3 to +11, right? So from start to intermediate is 4 units. From intermediate to end is 14 units. That ratio is 4 to 14, which reduces to 2 to 7. 2 parts on the left, 7 parts on the right. So 2 to 7 would be the reduced form, and I have choice 1.